And then I will introduce our friend, which we're all super excited about here. Let's see here. Okay. All right. Yay, we're there. Everything's working. So yay.
Tanya, I assume you've got links today? Okay.
Okay, perfect. Well, we're live from all over the world. And we have a very, very special guest today. Our friend Adrien. And most of you people probably know who Adrien is. But if you don't, he's the infamous Aurora chaser out of Norway that makes all these beautiful videos and pictures and things that we're all pining over all the time. But he's also a engineer and photographer, cinematographer. Teaches classes, both beginner and intermediate, in Aurora. And yeah, we're just super thrilled that he's here to just have, we're going to have a little bit of informal discussion. I think he has a presentation he wants to show too. But yeah, we're just going to chit chat about Aurora and kind of where all this is going and see what happens from there.
Yep.
So,
as in we have no idea where we're going. And I like that.
I'll let him take it over. We'll start. If you want to start with, I don't know, presentation, or you want to talk about current events or whatever, I'm totally game. So, okay.
I think beginning topics were current data works pretty well since we technically actually have something to talk about.
We do.
Which happens every single time, I swear. We are derailed in some way on every presentation.
I know, but that's what makes this so much fun. It's like, you know, we never have anything planned. Oh, we try. We try to have things planned. No, we don't. So.
You can't really be unplugged if you have, a plan, an actual structured plan.
So anyway, I think...
Point is, let's go to...
Yeah, let's talk about it.
Well, if you want to do any sort of intros, Adrien, while I'm pulling up some info.
Do it to it. Yeah, so thank you for having me, first and foremost. I'm super thrilled to be here. And like I told you guys, it's an honor to be here because I think what you do is just very, very important for the community. I think the Aurora chasing community is on the rise. More and more people chasing the Aurora, and it's so important to get the right information out there. So what you're doing is so important. I cannot stress this enough. So thank you for having me. This is an honor. So yeah, I'm not sure what the plan for today is. I have this presentation that I do during my course as a backup.
Okay.
There are some things that I think perhaps we want to, start talking about. Maybe after Christian, you want to start talking about the data. But I think, yeah, that's, if we keep this informal, then perhaps it's better this way.
The more informal, the better.
Yeah.
Yes, I agree fully. So presentations, of course, are nice, but not necessarily needed, especially when I like the idea of an open forum at this point because there's, now that we have actual data to talk about, but there's a few topics I want to pinch on too, which specifically going forward with the difficulties in giving accurate information because of the misinformation you have to fight against on a regular basis in order to get people the correct info. Which I know you go on tangents on your stories quite frequently, which I appreciate a lot because then I'm able to reshare those or at least add my own pitch to them as well. But yeah, I definitely want to touch on that. But we had some activity last night. As some of you know, I'm sure, in fact, a lot of people from the Ohio group were outside trying to get the lights. Unfortunately, it was not quite something for us. We had, I want to say it was 2 impulses, and wow, that's a lot of missing data. Let's go to the active. There we go. We had 2 different impulses, which makes me wonder. I guess we need to have somebody pitch in there as to what exactly were the 2 impulses. 2 different CMEs, maybe a weird shock combo. Really not sure, but we had the strongest IMF field I've seen since October. It hit 30 nanotesla. And unfortunately, not much of that ended up being negative VZ. In fact, a very small portion of that shock was. Enough to start driving force and get some decent high to middle latitude aurora, but not very much after that from the looks of it. And then debate is still open as to whether or not we had a fluxrope at some point, but it looked like at least a northern axial field at the best. So it didn't really come to matter very much. But what do we have, a G1, G2 warning? Or
Well, this is where there is some disagreement, and I can probably share some magnetosphere data
oh
on
yes,
this one.
please.
So can I share the right screen?
All yours.
Suppose I can. So this is auroral electrojet. This is one way to kind of quick and dirty look at what's been happening overnight or happening now. We had some disturbance in the magnetosphere even before the CME hit. So electrojets were definitely having some nice activity. There was a substorm earlier. You could see it right there.
Mhm.
And then it sort of settled into the convection pattern where there is some energy transfer on the day side. That's pretty equal to what's happening on the night side. And that can kind of brew for a while before it gets to substorm. But when the shock came, it just knocked the entire system into major reconfiguration, and we had very beautiful substorm. I was outside trying to do some desperate shots of clouds, which didn't happen.
Hey, I saw pink.
Same here.
I saw pink.
That's from a different date, and I thought I
never
saw
mind.
pink, but I'm not convinced there was any pink. So I
Fair.
have to be honest with myself, there was nothing, just clouds. But nonetheless, that arrival pretty much knocked us into G1 off the bat. There was a G2 alert that was posted by Met Office that was not corroborated by SWIPC, unfortunately. So we have some disagreement as to what magnetometers were showing. It was pretty strong. One way or another, it got some nice activity right at the time of shock impacting magnetosphere, and after that, it subsided very quickly. Some nice maybe activity for mid-latitudes, kind of higher mid-latitudes, and then it settled into high latitudes. There's still enough strength in the total magnetic field to still drive a show and some reconnections, but it's just not enough to move it out of those high latitudes, unfortunately. So that's where we at.
I like looking at the upper Aurora index. That you can see right when the impulse hits with that little spike right before the giant drop down in the lower one.
Yep, precisely.
Like small
right
positive
there.
and boom. But yeah, it was a standard. Looking at stack plots, especially, that went down. There was some depth to those bays. Didn't look like it got very far south in comparison to what it could have been, though, if we had more southern BC. I know that people in northern Ohio were trying to catch things too, but no one wound up finding any or seeing anything. Full moon didn't help.
Yep, but that's where we at. So some smaller substorms are happening, but
it's pretty much over for
yeah.
mid-low latitude, especially for the U.S., since there'll be more time for it to dissipate. Story of the year.
As usual.
Unless you're in high latitude.
Yeah, great timing for arrival for North America, but the weather.
Not so much.
I'm not complaining. It was mostly unexpected.
Yeah, that's true.
Like, I woke up at 5 a.m. and saw it. It's like, oh, well, this could have been cool.
I was up for it. I was waiting for the substorm out of that convection pattern, and then the shock came.
It was like, boom.
It's like, there you go.
That's one way to drive a substorm.
Yeah.
And that's pretty much current data, at least.
Yep.
I guess, I mean, there's still things that are kind of expected to come, because there's just a mess that's been happening. Well, what we were just talking about before we came on, what did you say, the Met Office is saying that, hey, just expect things this week? Basically.
Yeah, pretty much. Met Office was not entirely sure that they caught every CME and stuck them into a model. They're saying that there is just a lot of on-disk activity, and it's really hard to assign specific signature in coronagraphs to something that happened on the disk. There's just so much going on. So it's possible there is something Earth-directed, but we'll have to wait for L1. So don't put a lot of faith into models at this point. We really don't. None of the offices are sure of what was happening on the sun and what was thrown our way as opposed to sideways. We have to wait and see.
Expect something somewhere at some time.
Pretty much.
Yes.
Cool. My
above
favorite.
Above the clouds.
Yeah. So anyway, that's current events.
That's a fun topic, at least. So let's go into education in that case, since that's, what we're all here for, really, is the education of people and trying to expand knowledge to anyone and everyone who wants to either know more about Aurora, see Aurora, or just really likes the data and wants to dive into it. In my case, when I was younger, since, latitude 40 degrees, you're not going to get much anyway. But the difficulties that are involved in that. So, Adrien, you've been involved in this way longer than I think most of us have, especially me. What are, I guess, your takeaways on how things are right now compared to how they used to be in knowledge?
Well, I think the that's the issue because on the one hand you have the science that is in its this field is, let's just say it like this, is in its infancy.
Accurate.
A lot of research is being done and conducted at the moment, and we've had some studies dating back to like the 60s and the 50s and even earlier than this, of course. But comparatively to other fields in science, it's relatively in its infancy. And also, on the other hand, we have the rise of aurora tourism. And I feel like there's such a huge gap between the two worlds. And we're sitting there, like a few of us, and we're trying to bridge this gap between, the two worlds. And I feel like it's very difficult to do it in a way that is accurate for both worlds and also, yeah, that sort of like compiles the data, the information in an easy to understand way. And so that's why I think you guys are doing a marvelous job because it's so hard. I speak from experience, so hard to put things and to try to take like everyday life examples to sort of like show people, yes, the data are important, but also the field will show you that even with certain data, and I think that's one of the subjects I wanted to get into today,
Sweet.
is that you can have like two similar solar wind data and then have completely different magnetospheric responses and auroral responses. And like especially nowadays with like when the magnetosphere doesn't seem to be connecting the right way with the solar wind, and people are like, "But look, the solar wind looks so geo-effective and so like it should create great aurora," and it actually doesn't. So I think there's like a big job to do or big work to do to be done here in this area. And my hope is that more and more people like you guys and others can bridge the gap between the two worlds and hopefully spread out the right information. Um, and yeah, so on this topic, yeah, I don't know if I have like specific slides, but and maybe you can relate to.
Yes.
I'm getting a lot of times where, for example, like similar solar wind data would not give you the same aurora,
I think
what you think could be. Yeah.
that was one of the biggest things the eye-opening things to me, and actually kind of like when Tanya came into the loop too, because I was seeing this like for a long time where the preconceived notion was you could have a negative BZ, and if you have that negative BZ for hours and hours and hours, things are going to be good. And that's not the case. And then that's when we discovered a thing called steady magnetospheric convection, which which doesn't do much. So yeah, that's to your point. That's like kind of the question, and how to navigate that, because how the magnetosphere is actually responding is very different than just, hey, this is the black and white solar wind data and expect this to happen, because that's not what's going to happen a lot of times.
I always put it this way, is like I always tell people to imagine solar wind, or sorry, like space weather as people, like different people with different personalities. Like the solar wind knocks at the door of the magnetosphere. It's like, of course, it's like an image, a metaphor, but imagine the solar wind knocks at the door of the magnetosphere, and each time it's a different person with a different personality, different traits. And the magnetosphere is going to respond in a different way. So imagine your parents knock at the door. Of course, you're going to invite them in if you're the magnetosphere. Or if it's the postman, of course, you're going to ask them to hand you the mail. Or if it is, I don't know, the Jehovah's Witnesses, you're going to tell them to, butt off. So And even within these people, you can have different personalities, and they can have like different news and different things to say to you. And of course, you're going to react a different way. And that's the same way with the magnetospheres. Like, yes, you have these data and they have these characteristics, but I would really like people to appreciate space weather more, in a qualitative way, instead of like being
Here are
so.
the numbers.
Yeah.
Yeah.
Of course, numbers are important, and they produce something and they do something, but also quantitatively, that's super important. For example, a CME is not going to give the same auroral response as a CHHSS, as a CIR, as a sector boundary crossing, what you have.
Yeah.
And when you realize that in the field, you're going to, oh wait, but the aurora is like today is like pink and green and moving fast, and in a week, when you have a CME, oh wait, that's like super slow, and that's more like green and red, and you realize, wait a minute, two different events, two different responses, and even within them, you have like a whole bunch, like a whole array of different responses. And of course, you only gain this knowledge when you're in the field and you try to study like webcams and stuff like this, but it's so I don't know where to begin, because the story would be, pages long.
Way too long. Yeah.
I mean, it's cool because on one hand, it can be frustrating, especially for some of us that don't come from the science background and trying to understand papers and things. But on the other side, it's super exciting because it never is the same. So it's always different. And like with Milky Way photography, as much as I love it, you can kind of expect it. It's going to be here, for every day, basically. Changes throughout the year a bit, but it's not going to change. Aurora is very dynamic, and it's never the same, ever. So I find that really kind of a driver to keep chasing it as well, because you never know what you're going to get. Sometimes it's really,
I have
really
an
cool.
example of that as well. I mean, I would say going back to the two times that I found the aurora in my backyard were not really special events or special occasions. And we've had negative BZ in that sort that wasn't even close to the response we had. But even with the same type of solar wind, and I want to say I even have the data up, it was not like it was fast solar wind. It's not like it was -10 for a while. Like, that's maybe G1 level substorming, but we had two substorms that were naked eye here in my Portal 8 town. I mean,
Yeah.
and that's not like that can happen not only because of that solar wind data, but then what had happened before it influenced it and what happened after influenced it. You have special occasions each time that you have to look at. So I think arguing against, of course, you come across the people, like, for example, the northern hemisphere or the northernmost polar areas. In tourism, it's mostly soft serve and KP numbers. Why? Because it doesn't really matter. If there's any activity, if the KP is slightly elevated, they're going to see stuff. So why would they bother correcting it and learning all this difficult math and how to read graphs and data when they don't really need to? But then that, of course, hurts everyone trying to learn it. And then they come down to middle or lower latitudes expecting the same behavior, and it's just not.
For the record, you open this kind of worms right now, the KP index. So if we're getting into this subject, that's on you.
It was only a matter of time until one of us dove into it. I can't say that's a surprise.
And I think one of the issues that's underappreciated is, taking your analogy, Adrien, when it comes to somebody knocking at the door. It depends on what's going on in my house too, how I'm going to respond. I don't know. Sometimes I may not be up for chatting with my parents. I might invite them in, but try to make a visit short, because my kids kept having screaming at my ear all day long, and I really want some just peace and quiet, not communicating for a long time. So it really depends. Or yeah, if I have Jehovah's Witnesses, it kind of depends how I'm feeling. How far are they going to go?
Yeah.
So the point is, you don't want to look quantitatively, generally.
Yeah.
And I love what you
just
just said,
something to add in.
Yeah, because so I actually, may I share something with you guys?
Oh, of course.
Yep, you should
absolutely.
have
You have free
power.
sharing abilities.
The only not super complex, but hoping not to.
Ooh.
But I made a little slide the other day that I added to my course, because you've been talking about it so much, and I think
Cool.
so. This is what Tanya is saying, is that the house it depends what's going on in the house. And mainly, the aurora on the night side depends on what's going on in the magnetotail. So sometimes the magnetotail is like in what we call a pressure crisis, and it's not going to respond, in the same way each time. It might do like this first phenomenon called the substorm, which you guys talked on and on and on about. And sometimes, well, you've also been talking about the Sawtooth events, if I'm not mistaken, a lot.
Yep.
Sometimes the solar wind is, in a certain way, and the tail is in a certain way, and then boom, very pressured. So it's kind of like the same as a substorm, but more, instead of like having like a big release, you have like small release in a quasi-periodic sort of way. And then sometimes when the solar wind is, a little bit more on the crappy side, there's not a lot of pressure in the solar wind and in the tail as well. Well, then you only have like certain types of reconnection and what we call polar boundary intensification. So we at high latitudes may get a little, something, but then you guys at lower latitudes and on the equatorward edge of the oval, you don't get the typical substorms that we get, like the big explosions. We only get usually pulsating auroras or pseudo breakups, as we call them. Like it looks like it's going to explode, but this band is actually directly going into pulsating aurora and very kind of faint aurora. So the solar wind is one thing, but Tanya, I think you really stress something very important, is that the magnetosphere itself can trigger itself without the help of the solar wind, without, the solar wind does initiate all this process, of course, but the magnetosphere is its own kind of realm and does its own thing. And you can remove the solar wind once the tail is initiated in one way or another. The tail is going to do its own thing, and it's so hard to study these things because we have a few satellites, of course, in the tail, but the tail is always kind of not in the same configuration. We'd love to, stay in the same way, but the problem is, for example, the reconnection area locus is not in the same place all the time. And actually, we've recently found out that you can have actually different reconnection bays or locuses or loci. I don't know if that's a word. So try to have this satellite, in the tail, trying to study all those things. It's so hard. So you can understand why we don't have, a lot of science yet on this, because it's very hard to study. I hope that made sense.
Yeah.
Perfect sense.
Yeah, it does completely.
Just adds to it.
Yeah, we're dealing with the same issue when it comes to satellites and the magnetotail configuration when people are looking at GOES magnetometers and trying to figure out when is it going to substorm. So it really depends where that magnetometer is sitting in the tail. Is it in the dusk section? Is it close to midnight? Is it very close to where a substorm onset is happening? You're going to see very different data. And you can see substorms being missed by GOES magnetometer. So everybody is after that right now in North America. It doesn't work for Europe at all because they're just not in the right position. But everybody, almost everybody is chasing GOES magnetometers. And
Yeah,
they do have their limits. Because
They do.
they're not covering magnetotail uniformly. They're not covering it. They got their own little sector where they're sitting at consents. The rest of it is just uncovered. And you just don't know what's happening there.
It's one-dimensional data.
Exactly.
I mean, you're going to get as much information out of that as you can with something that just has one degree of freedom.
Yeah.
What is the magnitude in this direction or this direction? And then that leads to the question, okay, as just an aurora chaser, why do I care about any of this? How does this actually help me understand when an aurora is going to happen? And what tool should I be looking at in that case? And I think that's really one of the better ways we have that can address, hey, let's shift away from the app-based numbers and looking at BZ and all that, and let's just start looking at what magnetometers are saying. And that's where you get at least stack plots can be mostly useful in this scenario, depending on where you're at. I mean, I got to say that at least 2 substorms I was able to catch in my backyard were because of the magnetometers and the stack plots. You see those going off, goes off. Maybe we look at Glendale, for example, that can decrease as well. But you want to figure out truly as an aurora chaser, especially in the lower latitudes and middle latitudes, you want to know what's going to be more effective in letting me see aurora, because we don't get the luxury of hit or miss. KP5 roughly means this. That's fine because, Alaska or Upper Canada. we need to catch substorms. There's no other way, unless it's an October event or even October event really counted as something we really needed to know because we had SMC Aurora for almost 2.5 hours before anything erupted there. So a lot of people I know went back inside before it erupted. So here I am at 10 o'clock starting to see some pillars and waves start forming and some beads possibly on the edges, thinking, oh God, a substorm's going to break out. Everybody get back outside, and it only lasts for 10 minutes, and most people miss it because they don't get outside in time.
And that's
So I think not only
yeah.
KP based, but then we needing to inform people that it's phases. There are no constant aurora out all night just dancing no matter what in this latitude. It just doesn't happen.
No, it's also important too. Is I know I was talking to you that day because I was shooting at downtown Chicago, where all the light pollution in the world is, and
Literally.
it was only visible during that 10-minute outburst. That's it, because then it just subsided right back into the light pollution again. So, being able to take all of this stuff out that's out there and figure out what works best for your location is important. And I think maybe that's where people get frustrated, is that there is no one answer. I mean, let's face it, we're in a world now where everybody's used to getting answers immediately. You know, it's this instant gratification type thing, and that just doesn't exist with
Nope.
this.
It's not nature. Nature
Yeah.
doesn't really
And
care if you want one answer.
and
Sorry.
with mid latitudes, you really have to go into more of a data integration approach where you look at the solar wind and you look at the magnetosphere response. You can't just look. You can look just at magnetometers, but that's going to give you part of the story. Then you don't know what's coming, and without magnetometers, you don't know how magnetosphere is responding, or to some degree anticipate the response. And without solar wind data, you're just looking, oh yeah, look at substorm. Like October 7th, for example, we had a sort of shorter Sawtooth event. It was clear-cut Sawtooth event. Very periodic, quasi-periodic, I should say. Strongest substorms where you see the brightening of auroral oval that's over wider degree compared to just regular substorm where it's very, very localized. And we had more of that SMC kind of, it doesn't look very exciting. I know it looks great at higher latitudes. It's very active aurora. But for us, it's just, what's the term we're using? The diffuse featureless arc.
Yeah, the diffuse featureless arc. Yeah.
Boring.
We were on location, lakeshore, just beautiful setting. Two people came up, looked at that bubbly pea stew, and said, "Oh yeah, it's boring. Let's go home." I'm like, oh, why? It's not even the best part. It's gonna happen. You just need to give it time. They left. Because, that's boring green aurora. It's not doing much. It really doesn't have those nice tall rays where you can see all over, and it actually exploded over entire sky eventually. It was overhead aurora.
You said that was the
with
7th?
one of the teeth, that October 7th.
I mean, that was one of the times I caught it as well. So that makes perfect
Yeah.
sense. And I don't think the data was even necessarily that terrific for what was produced, at least. For the equatorward descent of the aurora, it was the -10 for a couple hours.
Yeah, it wasn't.
I mean, that's
Oh,
decent.
it was
but
longer. It was
Yeah.
longer than that. And
what did we
because
we even hit G1 that night?
Oh,
I don't think we even hit much of a geomagnetic
don't-
storm technically in the KP index. Here, I'll check that actually.
my favorite location, I had it all to myself. There was nobody else there.
5.33 was the highest KP
there we
index
go.
registered, which means it technically wouldn't have gotten below northern Canada, the U.S.-Canada border.
Yeah, on your KP,
Wrong.
your KP discussion. So, what talking about these little outbursts and stuff. If you follow KP, like, I just keep thinking about all these pictures that I've seen throughout the year of super low latitude people have caught aurora, like northern New Mexico, Grand Canyon,
Arizona,
California. And if you look at the data, the KP data, it shouldn't have happened, but it did. So there we go.
AP-based visibility.
Yes.
There are actually so many factors that people don't know about and don't take into account when they use these KP line-based maps. And that is, for example, the height of the aurora that depends on, of course, the magnetospheric response and what's in the solar wind. For example, like a CME-induced substorm or whatever it is, like explosive activity, will usually create taller aurora in where particles are precipitate, but remain in the upper part of the atmosphere, whereas a CHHSS has the tendency to really precipitate the particles deep down and create this low altitude aurora with mostly pink and green. I mean, I'm not saying the red is not possible there. It is possible. Yeah. I've seen it. But one thing is, like, imagine a CHHSS with a KP of, I don't know, 5.6, which is usually the case when CHHSS are geoeffective. Then that's going to create a lot of high latitude aurora because there's not a lot of pressure in the solar wind, and you're going to see these beautiful aurora, pink and green aurora. But then people are going to be like, oh, KP6, I should be able to see aurora because I live in the Great Lakes region, or I live like even further south, and perhaps I'm going to catch like, you know, a show or a substorm. And they go outside and they're like, I can barely see anything because the aurora is so low in altitude that they don't catch these things. They don't realize that the KP really doesn't indicate what type of aurora, what, you know, the timing, the location, yeah, so it's a can of worms.
And that can of worms is open fully now.
Yeah, I think that may have been the case actually for October 10th storm, when some people were disappointed with the visibility, because for the most part we were sitting under auroral oval, and there was not a whole lot of going on. There is some activity in the sky, but it's not explosive. It's not rapidly swinging substorms that do frequent injections, and you see the beautiful rays, or even a lot of activity right overhead. You'll catch it for those big injections, for the Sawtooth, but for the rest of it, it's just gonna sit there and do nothing.
Yep.
So waiting 3 hours to catch about 10-minute activity, that's fascinating. I saw fast auroral waves with both October storms. That was really cool. And without just sitting there looking at the sky and waiting for the substorm to break and knowing that it's going to break, but just waiting and just for me, that was an amazing experience because I saw some auroral forms I've never seen before. Not that I've seen plenty, but it was beautiful. But for a lot of people, it was disappointing.
That substorm kicked out a lot of shows I had seen in Alaska for the top 3 brightest, and funny enough, the top 2 were both coronal hole oriented, which means I had the pink fringes, but this one was absolutely the 3rd brightest I've ever seen, and it went from just that SMC arc to a giant red, it wasn't even a pillar, it's just a red mess to the west, and then all of a sudden, whoosh, you see the waves start, and it comes out dancing, and it gets tall. I mean, it was so bright. I love reliving that day because of that, but even just here, I mean, it was a Bortle 6, I think, where I ended up coming to. Latitude 40 degrees. I think my geomagnetic latitude is like 48 degrees. And it was the entire sky. I had almost overhead aurora, and we had a SAR arc to our south the entire night. It was a gorgeous night. But yeah, the point is that SMC arc was out for 3.5 hours, I want to say. From the time it got dark, the substorm was just ending when it got dark, the initial one before that. So we had just the color in there, and it kind of mixed, and then I saw a band on the horizon, and that grew and grew and grew as it got later and later. And yeah, I think 10:30 from 7:30 is when it finally started erupting. And it only lasted, 15, 20 minutes, maybe. But the idea is, you know, that's 3 hours. If someone's going to come out and look for 5 minutes going, it's nothing, I can't see anything, especially if they're in a city, and they go back inside, and half an hour later, it goes up and they miss it, and then they hear online it's happening, go outside, and it's gone, sorry. I have that happen a lot. And that's why I try to be on Facebook pretty constantly as like, it's happening. But for my Ohio group, I just go, hey guys, in between this time and this time, if we have some SMC patterns going, it's at least can roughly calculate when that's going to break again or how long it's going to take. So it makes it easier to tell them to stay out. And then almost always they catch it from there. Yeah. Awareness, I think that's really the more.
Yeah. And the thing is, we keep calling it SMC. It really isn't as pure SMC for the Sawtooth event. So what happens in between, it's just the gradual accumulation of magnetic flux in the magnetotail. But you do have convection happening at fairly steady rate. It just, you cannot transfer all of the energy that leads to accumulation. in the magnetotail and to eventual substorm, as opposed to really pure steady magnetospheric convection, where it's energy in, energy out, 5 hours. Sometimes even longer, but some of the events have been 5 hours. And you sit and wait for it to happen, and then nothing happens because it just gradually dissipates when BZ gradually rotates out. You get lucky if there is a sharp swing in the BZ, because that's going to trigger substorm. And all that energy that potentially was accumulating, it's just going to dump it right in one big swing. But if it's a gradual transition, it's just going to fade.
Yeah.
And then, this is where correlating solar wind with what magnetosphere is up to is really helpful. Can you predict it in just pure numbers, how good it's going to look? No.
Yeah.
We have a question that might be interesting to talk about more a little bit.
Yeah,
someone who wants to know more about Sawtooth events and what we formally mean when we're saying that, or the part of the team. Unless there's some active Aurora going on, Adrien, that you want to talk about. I saw you looking out the window.
Yeah, the substorm looks like it's breaking, or the substorm, I should say substorm. I should say explosive activity, because it's always hard to tell if it's a real substorm on the spot, but it looks like an expansion from a substorm that is breaking up just above us right now.
So jealous.
To see if I see anything, but with this light, no.
Right. it would be cool if, like, oh, look at live Aurora.
It's gonna improve. Negative BZ is on the way, so expect something more interesting. I would say probably an hour or so.
Yep, I can see it.
Yeah, I think in terms of the question, because of October 10th because it was a sea. I mean, we can actually talk about this again, because remember we were trying to find the flux rope in this, and you couldn't really.
And there really wasn't one. Yeah,
and it was just flat. I think I do have our presentation from that event analysis, so I can probably just pull it.
Yeah, because really, so it acted differently than what we thought, because it got stuck in the sawtooth type pattern, which is basically like magnetospheric convection, but amplified
on steroids.
So you get in these,
I think was the dramatic part.
These patterns where it just doesn't do too much for a while, and then all of a sudden it has these outbursts that were like quite spectacular. So yeah, but we'll bring that up so we can kind of talk about what we mean here.
I don't have solar wind data from that day.
Okay.
I do have GOES magnetometer, because
I mean,
most of that sawtooth event pattern. Yeah, most of the sawtooth pattern that we saw was for the flux rope. So, Christian, if you feel like pulling up the solar wind data, that would be awesome.
Way ahead of you. Already got it.
All right. Do you want to start there? Yay!
Oh, no. Except I went too far. Let's see if that got it. No, maybe. Yeah, there we go. Yep, here we go.
Yeah. Oh.
Yeah. So that second ramp up, that was also the moment I decided, all right, I'm going outside. But this period then. At it stayed minus 32, minus 40 for, 2 hours? And then actually just looking at the full magnetic field, yeah, there really wasn't much. I mean, BY changed momentarily as it just grew deeper into the west, but beyond that, it was constant. There was no real rotation or anything.
Yeah, and by, I would say, 7 p.m. Eastern time,
so
the substorm current wedge, so our Auroral Oval, was already kicked out of Canada. So when flux probe arrived, we already had a very disturbed, or core CME, because there's no flux probe. It's CME core. The temperature clearly dropped.
Yeah.
And it was pretty much, we were sitting under a Auroral Oval even before the core showed up. So with that core maintaining near constant negative BZ, this is what we were expecting. So I'm going to share the GOES data. Oh, I have it conveniently marked, actually.
Oh, yeah, because that was a pretty characteristic sawtooth then, if I remember right.
Oh, yeah.
It's very apparent what was going on.
And same actually was for magnetometer response. So I'll pull up the stack plot too. So let's start there. So, okay. CME arrival with a lot of magnetopause crossings for both magnetometers. You see those swings that are pretty substantial into deep negatives. So that's what it feels like outside of the magnetosphere. And then I think, when was it? It was, yeah, about this time. The flux, well, the core arrived, and you start to see the Sawtooth. So there's one swing that's going up, so that's one substorm. There's another substorm right there. And in between, you have slowly stretching magnetotail, so magnetic field strength is decreasing, at least as felt by GOES magnetometer. It really is not decreasing, and magnetosphere is not cracking. It's doing just fine. It's done that
So no
for
cracks in the
ages.
magnetosphere?
No
No
cracks.
cracks. No cracks in the magnetosphere, no crack for the magnetosphere. Stop it. And then you keep having those sawteeth where you have that injection, and usually, basically, that's a bunch of particles that's flying right past the magnetometer toward Earth. And you have a magnetic field that's reconfiguring very, very rapidly. Because that happens very rapidly, you have brightening that doesn't last very long. And then you back to sort of more boring convention and kind of not particularly exciting looking aurora. But we had pretty decent 1, 2, 3, like 4 sawteeth out of that core.
And what's cool
Which
is they're
is-
like 3 hours apart.
It
Almost
it
exactly.
was pretty good. That seemed to be kind of the natural response, natural cycle in the magnetosphere in response to fairly steady driving, fairly steady BC. You could see it in the stack plot in Charisma. So this is what was happening in the Canadian magnetometers. Again, this is CME arrival, nice substorming because even the sheath had fairly strong negative BZ. It wasn't constant, it wasn't maintained. So you see frequent substorms and frequent reconfiguring events, and then you fall into this basically sawtooth pattern. That's pretty
So
typical.
it's literal. So for the definitions being saw teeth, they look like,
Sawteeth.
teeth.
Yeah. And
From a saw.
what's interesting
Literal.
about the history of sawtooth events is interesting because initially it was picked up as particle flux. So people were measuring electrons and protons that were in Earth orbit as they were picked up by instruments in orbit, and they've noticed that there is a pattern with substorm with a magnetosphere with particle flux. Only later it was connected to what was happening to the magnetosphere. You have magnetospheric physics that's separated into silos, so they're each studying their own field. This group is studying particle flux. This group is really studying more of the ground magnetometers and more of a magnetic response. And they never say hi to each other. They don't talk to each other. And as far as what Aurora is doing, you may not necessarily have a group that's studying particles even be interested in what Aurora is doing because they're worried about what is happening to the satellites in low orbit and how particles will affect it, because it will. That's a very, very strong flow of particles. You're gonna see some nice charging. But the magnetic response, where you will see disturbance in GPS functioning, that's a totally different field. So they don't have to talk to each other.
Right. And that's a whole other problem. Like
Yep.
where you get everybody just in their little bubble, but realizing that this little bubble actually does kind of affect other things. And that's kind of what we're all discovering on our little aurora chasing journey. It's like, wow, this stuff is all kind of intertwined a bit. And yeah.
During Tamitha's presentation at the summit, that was the first time I heard that as well. She's like, you've got all these individual areas that are being affected from geomagnetic storming that aren't really talking to each other, but you really do have all these connections, and we need to have an actual network between them all so that not only can we get more understanding out of it, but then people are just more informed in general.
Like the ham radio community. Like, they've been in tune with this stuff for a long
Radio
time.
Aurora is awesome when
Yeah.
you look at it. Note. Just the properties of being able to point your antenna north, and even though it's nighttime, still be able to communicate with other people.
Yeah, that's pretty
Very
wild,
cool idea.
to be honest. So, it's been a fun ride. I almost wanted to become a ham radio operator, but I don't need another hobby. I don't. So I'm not.
Especially with having a drone already.
Yeah, I already got a drone, so it's fine. So anyway, that's October 10th. So we've talked about that a couple times now, but it was just so weird. It was weird because I think we were all expecting, because of the location of that flare in CME, we were like expecting to get a clean flux rope out of it, and really didn't. So that's another one of those anomalies, I guess, that always surprises us.
And we expected strong and spectacular storming because of that strong negative BZ. That didn't happen. It was more those periodic, stronger brightenings of Aurora, but it was not particularly exciting for mid-latitudes. I'm sure that was more interesting for higher latitudes, and you probably had it south of you because everything moved. I mean, I saw a few magnetometers being just kicked out of Auroral Oval altogether.
Yeah, I think I was under clouds back then. But...
Okay. For once you got out of it.
Yeah, for once. That's okay. Well, probably would have been in the horizon in the southern sky with some, maybe weird patches in the sky up from there.
That's just weird.
I imagine polar aurora would have been kind of funny comparison.
But that's one of the things that I wanted to piggyback on is it also teaches you a lot to be under the oval a lot of the time, because you can really, really see what's going on. It's like the magnetosphere is, of course, like half fluid, half magnetized, but you can still see these movements of these patterns of convection, going like when it's like negative BZ, you can really, or BZ, you can really notice when like the curtains are really going from your northern sky to your southern sky to kind of like add pressure to what is the growing band, and then really at some point release or not release depending. But you can really see these movements, and then when it's positive BZ, the opposite is like it pushes from the south towards the north. And I think understanding that is, like experiencing that at least once in your life. It's like, it was one thing, of course, to see it from mid-latitudes, and I started from mid-latitude, so I know where you guys are, seeing a lot of the time, but also seeing it at least once in your life from like what's going on above and what's going on the poleward edge of the oval and on the equator edge of the oval. And sometimes you're in the polar cap, like sometimes we are at high latitudes in the polar cap. You can really tell there's actually not much going on, unfortunately, except for midnight. But yeah, it teaches you so much about what the magnetosphere is doing. And I always say, if you know what the magnetosphere is doing, you know what the aurora is doing, because it's just a byproduct of this magnetospheric response. At least you can anticipate a few things, if not everything, of course, but you can anticipate what's going on.
And I mean, we pretty much lived off that. Our 2023 Alaska trip in March, it wasn't terribly too much great data. In fact, if I remember right, the best data we saw was like -5 or -6 BZ. But we were high enough in latitude that we caught almost every magnetic midnight substorm that was there, because we just knew when to go out. So 2 a.m. hits, and it starts showing up, and then it's like 20, 30 minutes. But the idea is we know what it did under quiet conditions, so we knew what to expect and when to catch it. So yeah, just to add to your point, I agree. Increase your understanding. Not to say it's easy, of course, but this is, okay, this is going to go into another tangent now. It's not an easy field, and of course, even us, we get confused 80% of the time about what's going on, because everything changes so much and there's so many different variables combining together. That's why you need to trust the people that are doing it for a living. First, the researchers up there, then you've got the people that have been in the field, maybe actually in the aurora zone to see it, so they know how it reacts with certain magnetometer data. But you can't rely on your app, and you can't rely on specific people that really haven't been involved in it that long. If they're using the idea that, oh, we've got a negative BZ, we're gonna have aurora. Sure, but what kind, when, how far down is it gonna get? Like, you can't answer those questions with that. There needs to be more trust in the people that actually have the ability to decipher the data, at least in some reasonable sense, so that we have some sort of authoritative figure. Because right now, anyone can pick up any real-time solar wind data and go, this happened here and that's that. And who's going to really say otherwise, except everyone's going to get on some sort of side with them. So I think we've just got too many people trying to jump in and have the expert status, and maybe for even the possibility of being an influencer involved in it. Like, oh, look, I'm big in Canada and I get to see the aurora, but I don't really get the information, and follow me for this. The idea is we have too many of those people, I think, right now. It's too and this sounds kind of harsh, I think, but too cliquey of a field almost. And there's just not enough of recognition of the people that really know what's going on and really can say how we should be looking at this data and what we should be doing with it. Because, of course, it's not like any of us are unwilling to teach. In fact, I would say all of us, all four of us at some point, that's a big goal, is just teaching what we know so we can learn more and understand more and help others do the same, because the Aurora is amazing. So we want other people to see that. But when you're competing against many different areas, many different groups, many different websites that all say different things, who do you listen to? Especially when you don't know anything about the field. Well, you're going to dive into what you can understand, and what you can understand is the single number. Again, going back to either the KP or the ovation model, they have their places, but you can't become an expert by knowing that information only.
Amen to that.
Nice rant.
I needed to rant about that for a minute. We just need more trust in the people that can decipher data. That's really all it comes down to.
But we have a question to get to.
Oh.
We do have a question. I think it is from Alistair. Any comments on longitudinal variation? The DNB satellite imagery shows very interesting variation that way. What helps explain that?
That's a good question.
That is a good question.
Very good question. Could I share?
Want to take it, Adrien?
Yeah, sure.
Yeah, by all means.
Share away.
Ooh, I was just waiting.
Guest of honor here.
Just waiting.
I was just preparing my. Okay, so here is like the latest. It's a scientific representation, but it's the latest understanding of the different features that we know of the oval as of 2024. At least 2022, because I think this book was republished in 2021 or 2022. By the way, it's Auroral Physics by Dr. Knudsen. I'm not sure if I'm pronouncing this correctly. It's a gold mine of information. Yeah, so one thing, I think one of the biggest misconceptions about the Aurora or Aurora chasing is to believe that this belt of Aurora, which we call the auroral oval, is consistent all along the belt. And to think that Aurora activity happens the same way from the same sources and throughout the same processes along the belt. And it's far from being the case. Actually, the scientists and the current understanding of this is that there are actually as many as, I think, like 11 different forms of aurora, and I don't think we're actually even finished discovering new forms of aurora. I mean, I think it was very recently that citizen scientists came together to publish this booklet about the different new forms of aurora, like
all the different months ago, I think.
Yeah, there was a few months. That was just amazing. I'm actually on low-key part of that group, but I'm in the background. I don't even receive emails, but I sent in some pictures and I saw what they did, and it's just wow.
It was really good. Yeah.
It was so good. And so what this shows is that it shows that longitudinally, you can see that you actually don't have the same types of aurora not created by the same processes in the magnetosphere. Right? For example, in the evening side, what we call the evening sector, you have, already two different types of aurora, depending on if you are at high latitudes or lower latitudes. By this, I mean very high latitudes here in J, and A is more like higher latitudes. This is usually a more discrete, quiet aurora, like east and west arches. Then you come into this substorm sector, and then you have like more mesoscale dynamic forms of the aurora. You also have at lower latitudes, you also have these SIR arcs. You also have closer to midnight the Steve features at very low latitudes corresponding to like closed field lines. And then so you really realize that you really have different types of aurora depending on or if you are at like, I don't know, 6 p.m. or midnight or 2 a.m. And then you also have, because of the tilt of this oval and the rotation of the oval, of the geomagnetic pole around the geographic pole, you also have the displacement of this oval depending on your location. For example, in Norway or northern Scandinavia, you're going to be in the substorm sector roughly about 7 p.m. to 2 in the morning, versus in Alaska, because of this east and west displacement, you're going to be more into the substorm sector around 10 p.m. to 4 a.m. and maybe a bit more. So there's so much. And then on top of that, this is like a sequence that I took from um, this storm from 1998 showing a what is the result of a big, impactful solar storm. And each picture is taken, this is, of course, the night side oval,
Mm-hmm.
and it's taken at 5 or 4 minutes intervals. And you can see that actually there's a lot of things going on in terms of latitude, but also in terms of longitude. Sometimes the intensifications, and the cool thing is you don't need to know squat about this. You understand that the brightness means good aurora. So you can look at where the brightnesses happen, and you realize sometimes it's in the morning sector, sometimes it's more around midnight, sometimes it's more all over the place, like here, sometimes it's in the evening sector. And that's the thing, is like with CMEs, for example, they induce such a wider response of the magnetotail that you can have brightenings and auroral shows at, really different parts of the night side oval. And so you can be sitting in, I'm going to show you an example that I usually show for sometimes how substorms look very local. This is not an actual picture from, I can't remember the source of
nice.
it. That's showing the southern oval, southern hemisphere oval. And you can be sitting in, for example, one here in Iceland. If I'm transcribing that into the northern hemisphere, let's just say, okay, you're sitting in Alaska, because maybe your audience is more US based. So imagine you're sitting in Alaska. It's like 10 p.m. You're in the evening sector, and you're only looking at these, bands above your head that are quite stable and don't do much, don't explode. They may flare up, but not really. And then just 2 hours from you, longitudinally, you have this substorm expansion, which is really local, or brightening, which is really local. And you would see a flare up in one, but you would never see this spread of, super bright and dynamic aurora. And you see also, if you sit in the morning, like too far in the morning sector, then, well, you may see this pulsating aurora just, brighten up, but then you will never see this super bright substorm. So yes, there is a lot of longitudinal variation in the aurora, and it's so complex. And even me, who has like more experience perhaps than than the average person chasing aurora, sometimes it finds ways to surprise me. Sometimes, I'd be like, oh wait, there's a substorm right now, I should be seeing something because the theory tells me this, and yet it's far from being the case. So we can learn to anticipate the events with the theory. And yes, the substorms, they tend to happen around 10:30 magnetic time, plus minus 3 hours. But then there's always going to be variation, especially when we have CMEs. There's so much longitudinal variation in this. So I hope I answered the question. So not an easy answer.
Brilliantly.
Go back to what you and Tanya were saying. Not an easy field.
No, I think you covered that well, though. And having these pictures, especially these satellite images, really explain it. Because you can see it. You can see the difference just right there. So I had another interesting question. I'm not entirely sure how to answer because I think it's a lot of situational. But it's... Let me see if I can... Let me word it correctly here. Why,
Is that Jesse's?
Yeah, why photos of aurora at mid-latitude seem to be brighter, more intense than photos of the aurora from directly underneath. And I'm having a hard time with this because I've seen really bright aurora and I've had really bright photos of aurora from up in Alaska.
Both sides?
And I'm wondering if it's just because we see a lot more red at mid-latitude because we're looking at it kind of like this versus underneath. And maybe it's a color thing and not so much the green.
I think situational is a good answer to it too, because going off of Adrien's previous statements, some aurora is very high altitude and it affects it more strongly. So CME impacts, for example, so it's going to be seen more and more colorful, whereas the vice versa coronal holes get to the more in-depth ones in lower altitudes. which would make them dimmer from farther away, but brighter if you're underneath of them. I think it's situational, though, really. I think you could pretty easily find cases, now this is just my take on it, where you're going to have both. It could be brighter. If it's a really bright show, then yes, it's going to be bright when you're seeing it from the distance, of course. But if you're underneath that, it's going to be just as bright. It's not like brightness differs in that sense. In fact, it probably is more bright because it's underneath of you and has less distance to travel. That's my thoughts on it.
I asked her like
Some
if
of
it was
it.
a specific
go ahead.
event because during May, we were all up in Minnesota, and the whole time I'm thinking, like, I was seeing pictures from Ohio specifically and some of these lower latitudes. I was like, why it looks way better down there, and I think it's because we were kind of north of it really at that point, and a lot of the bulk of the Aurora band was south. So it seemed like
That's
to
when it
me,
hit my south sky.
yeah. So I was like, well,
Ooh.
yeah. So it's kind of, I think to your point, yeah, situational perhaps.
Some of it may be more of a point of view as well when you're looking at Aurora from the side, because how much of the front you're seeing. So think about it as there's essentially, you're looking at the wall from the side. So all the injections, all the colors, they're stacked as one single front. That's what you're seeing. You're seeing really, it's really a 3D, but you're seeing it in a 2D projection. So when you move that up and it's over your head, you're not seeing everything that's happening to the sides. You're just looking straight up at it, and you're seeing sort of less particles that are able to generate the color for your angle of view.
Okay, yeah,
So
actually,
it's
yeah.
just as bright when you're looking from the side. You're looking at the same event, but it's sort of, you're looking at a different thickness of it, so to speak.
Yeah, that
So
makes a lot of sense,
you're gonna catch less photons, less particles that are capable to transfer the meaning of light this way compared to when you look from the side. So it's this thickness as opposed to a kind of single, more of a sector of it that you're looking at. So you're just not going to see it. It's the same aurora, and it's going to look very bright, particularly early, shortly after the onset of it, in early expansion when you have like really bright explosion. But you're not going to see that overhead because you don't have the stacking anymore.
No, that makes
and all
sense.
that, and we haven't even touched the photographic aspect of it. The actual, what kind of settings are the cameras using? Are they actually picking up more photons? Is it going to be brighter? I mean, there's a couple different ways for that to work out.
No, that makes total sense to me, honestly. So yeah.
Yeah, I think that was a really good explanation, Tanya. Like the there's always like it's always the same question when people ask me, oh, they come here and they want to experience the aurora for the first time, and they look at it for the first time, and of course, unless they happen they happen to look during a substorm expansion, they're going to be looking at faint aurora most of the time, and they're like, oh, is this aurora? Like, yeah, it is aurora, and it's not that bright usually, right? I mean, unless it explodes, it's not really that bright. And I always tell them, so because they ask us, why don't you see colors with the naked eye with this type of aurora? Well, I try to explain to them, sometimes I have like street lamps in my area, and look at this street lamp, and you're seeing it's yellow, right? If it's sodium. And they're like, yeah, I can see the color because the light is so concentrated. It's so bright that your eyes can pick up the colors. And I think you had a long Space Weather Unplugged actually about this very topic.
Yeah, we did. About the naked eye visibility.
Sure did.
Yeah.
And it was like wow. So I actually learned a few things in there.
That's
so
awesome.
thanks. And
We
yeah,
sure
of course,
hope so.
Yeah, I did, and so I tell them, well, compare this to this light spread out over like a lot of area, and imagine maybe if you regroup this light into one single point, yes, it's going to be that bright, and you're going to see this color. But if it's so diffused that the particles are spread out, then you're not going to see anything because your eyes are just not made to see this well in this situation. So.
Human eyes really do, in comparison, suck when it comes to viewing things in the dark. We really aren't meant to, other than just brief outlines and ability to avoid falling into holes and hitting trees. But
Yeah.
Oh,
I agree. I have to say I agree, but I need to give our eyes, there's a silver lining, or there's like we always say, oh, the eyes are worse than cameras. Actually, no, they're worse in colors, but with dynamic range, they're actually better
uh,
because
Yeah.
if you took a picture
yeah,
of like the moon, for example, which is present in our night sky right now, it's so hard to expose for both if you're not taking two different pictures. You're either going to expose to the moon, but then the landscape will be dark, or you're going to expose to the landscape, but then the moon will be blown up in terms of highlights. And our eyes can both see the craters. I can actually see the moon right
Yeah.
there, and I'm
yep.
going to be able to see the aurora at the same time and what's going on in the foreground. And I think we need to give our eyes, a little bit
Yes.
of
A
something,
little more credit.
a little bit, yeah,
That's
a little
fair. And that's the same with the crescent moon. Then you've got Earthshine that we can see the sunlit side and the Earthshine at the same time. You can't do that with the camera. You just can't.
Nope, it
so
takes multiple exposures to do it. I mean, the same. It's true with the sunsets and sunrises too. We can see all of it really well, but the camera, you either have to use a graduated neutral density filter or HDR or things to see what we're seeing. So yes, Thanks for
It's the
thanks for
first
that.
positive point I've had for the human eye. So yeah, I do appreciate that viewpoint. One topic we haven't touched yet, unless anyone else wants to continue on with the learning education aspect of it, but we have apps we can talk about too.
Oh yeah, you want to plug your app, Adrien?
all right. I wasn't planning to, but if you force me,
Oh, I was going to force you. You didn't have a choice here.
You
I'm
know it
more
was
than
gonna happen. Well, at least with yeah.
all right, let's see.
Yeah, explain to us how it all works.
All right, so Hugo is a young French person who lives in Switzerland right now, and he's fascinated by the aurora. He's young, he works in the IT industry, and he's very good at coding. And he also discovered the aurora a few years ago and got fascinated by it. And we met actually in one of my courses, and he told me at the end of the course that, because I had mentioned that I've always wanted to do this kind of app where instead of being fed numbers,
Right.
the goal would be to land on a page where we could see a globe. The idea was to see a globe, and of course daytime, nighttime, and that would be to see the actual oval, and not from solar wind data, but from magnetometer data. And I think a few beta versions were made by scientists here in Tromsø, who I have to give credit to because he actually helped us. This professor, Magnar, super nice. And so, yeah, so the idea was to really land on this page and see the oval. Now, you don't see anything right now. You see the oval. I mean, you see the globe, but you don't see the oval because the point was, of course, if you're going to use magnetometer data, there's going to be pros and cons. And the pros would be, of course, you're going to be able to somehow locate the oval and give a general intensity for the oval, or at least tentative intensity for the oval. But of course, the cons would be because the aurora, especially on the night side, happens in brightenings and really like growth and release. Well, you're going to be at times where the magnetometer lines would be flat, and at times where the magnetometer data would be peaking, and of course, sometimes more than not actually, the magnetometers are flat. And unfortunately, when the aurora is weak, or at least when the geomagnetic activity is weak, or I should say the activity of the magnetosphere is on the weaker side, or at least not doing much, then you would have not like the ovation model that has this oval all the time, even when conditions are not good. Then this would be more like a real sort of situation where the oval is extremely faint. You can actually not see it if you don't click on it and see the score, which is out of 10. So 0.3 out of 10, this is almost nothing. And if you look at some of the cameras, you would see very faint aurora in the sky, which is what you see if you just pass your cursor on it, and you see this very faint growth band, which I think the substorm is going into growth again, maybe, hopefully. Yeah, so that was the idea, is to give us what the graphs would say, but in a visual way, so that the people who do not understand the graphs, which are actually very hard to magnetometers, it's not the simplest thing to read. And I'm hoping you're going to make the session with how to read magnetometers at some point.
That's the plan.
I know
It's in the plans, yes.
Awesome. Yeah, so that was the idea, and then we kind of built on this idea. We implemented a few other things like a quick look page with the solar wind data, where we kind of built on Noah's version of this, but we implemented a few tweaks. So the ability to see if it's an error or not, for example, the ability to take this little time bar and do this, like zoom in and out, which I think was implemented lately in Space Weather Live, so that's awesome. We put the Earth bar, we put some gradients, which is always hard with gradients because they may mean something, but they also may not mean anything. And we also put the ability to see what the other satellite, the not active satellite, was doing in the background with these gray lines, for example. So it's quite easy to see when one satellite goes missing, or at least the data goes missing, to see what the other satellite is doing. So of course, it's far from being, the best tool. We don't want to be the best tool. We want to help Aurora chasers. And we kind of took some requests in and we kind of put this together. So people like it, great. If people don't like it, great too. People are free to use it. It's free. I forgot to mention, by the way. And we don't want compensation for this. We do this on our free time because we love this kind of stuff, this nerdy stuff. And the last thing I wanted to talk about in this app is this dashboard, which I think was a bit missing in the resources that we had so far. So I think Noah had this Aurora dashboard, but you cannot build your own dashboard. So the goal is really to choose from a pool of different widgets and put them on your dashboard, arrange it the way you like. You can have the solar wind, you can have webcams, you can have the model, you can have our own sort of like AE index. You can have magnetometers, you can have a whole bunch of different things with the like moon calendar and everything. So it's free to browse around. And we also take people's questions. If they cannot make something work, then they can contact us and we can help them navigate the app. Sorry, sorry about this.
No, that worked. I'm a big fan personally. I like the ability to set up your own charts where you want them and how you want them. That's kind of a big thing. I don't think I normally see with actually really any other apps in general. They normally provide hey, here's all the info. It may or may not be intuitive to look at or not, but here it is regardless. And here you can just pick what you want and what you find is relevant. I like going in a certain order because generally I would check things in certain order, stack plots first, and then I'd go down to see any sort of AE index and then solar wind conditions and then like solar flare conditions. So I can just set it up from top to bottom. Okay, here's my stack plot, scroll down, here's all the solar wind data, and I can just scroll instead of having to go to 4 different sites, which I know generally that's accessible in most other apps as well, but the convenience of setting it up your own way, I think, is something I'm a big fan of.
And then
there's a
I was just gonna say I think the questions were answered in the chat though, but so I'm assuming if we ever get more southern hemisphere magnetometers that you would include the southern hemisphere in this, right?
Yes.
Yeah.
So there's a big limitation in this app, and of course we rely a lot. I mean, the model from the homepage relies a lot on magnetometer data. And we were lucky enough to get, actually we started only with a few in Norway, Sweden, and Finland. Then we got access, like we could kind of like browsed around and we got access to some in Europe. We didn't get access to Iceland, so we interpolate the data. So for Iceland, unfortunately, like the Atlantic, unfortunately, is not super precise, but we get a bit more precision because of the magnetometers in Greenland. And also, thank God, we got Canada and the US, we got access to it, to them, I should say. And so we kind of like expanded the oval. And of course, you can forget about the Russian ones because of course we don't have access to them. But yeah, the idea would be, my idea was to extrapolate this, knowing that the oval is, about conjugate. but it's actually, that would be too many conjectures to, to really give something solid. So far we don't have access to any magnetometers in Tasmania, for example, New Zealand or Australia. We do have a few in Antarctica, but the main issue is we rely on the consistency of distribution of magnetometer data. And of course, in the southern hemisphere, well, there's a lot of ocean and there's a lot of water. So
Yeah.
until we do,
It's a magnetometer desert.
Yeah.
Yep.
it is.
Unfortunately.
It's a land disadvantage.
Yeah.
Yeah.
Yes.
We always feel bad for our southern hemisphere
there's-
friends.
There's a lot more limitations that I haven't mentioned about the model. So please, like, don't because we get a lot of questions like, why is this model not working? Why am I not seeing Aurora right now? But what you're really seeing is a reflection, an image of the magnetometer, like a stack plot, basically, like a huge stack plot with all the different things. And you need to keep in mind that the magnetometers, they do not 100% represent the auroral activity. They represent the activity of ionospheric currents, which is the result of the magnetospheric activity. So it's a proxy of a proxy, and yes, we can come to this model, and that's already, I think, a big step forward, but it has a lot of limits or limitations, and we are aware of them, and we put them all in this little about the model page. So please, if you want to use this, read this carefully, because we've explained what we've done and what we haven't done, and what's in store for the future, what we want to implement. So I think it's better if you start with this. I know it's a lot of text, but that way you can get a better idea of the caveats that you don't want to go into using this. Yeah.
Sweet.
But enough about it, maybe. I don't know.
Perfect. Thanks for the explanation there. And really, of course, it's a tool like all the tools we have. There's no one tool rules all. It's use all of them as much as you can to gather as much data as you can. Glendale's good to add into that. You've got, then just, well, I use Glendale and this app are the two really that I go to anymore. I can't say I've needed much else. The Glendale substorm strength is still a super beneficial thing to look at, but then you've got most of the other references in this app too. So I generally only use these two anymore. Space Weather Live is good for the push updates too, so I still use that regularly. Use all your tools is the idea. There's not one that's better than the other.
I agree.
Yeah, one note on Space Weather Live that I think I actually talked to developers is they do put speed and density as sort of two top things in the solar wind data, and really their auroral activity is more solar wind activity panel. I wish they could separate it, because when you really look at the auroral activity, it's at the very, very bottom of that. You have to scroll way past the solar wind to actually get to true auroral activity. And because how solar wind data is communicated is how it's perceived. So if an app tells you that those are top two things that we're putting right as you land on a page, they must be important. They are important, but they are more important for identifying solar wind structures than really a magnetosphere response.
Yeah.
Amen.
Agreed.
So is this happening when you cornered Marcel and Sanders at the Aurora Summit? Like left them with no way out, right?
Yeah, they kind of looked to the sides.
Oh, that's why we love you so much.
It's true. Yeah.
One thing I want to
fun.
One thing I want to rebound on is some of the choices that we've made, and I think people like developers, I think they make choices based on very intelligible and sensible processes, and because people came to us and say, why are you representing this as NOAA? Well, there are a lot of advantages of representing things as NOAA and not, for example, like Space Weather Live or any other entity. And it's because, we discussed between us, like, do we want to dumb this down to the way or to the point where it's easier to read, but at the same time, it would be slightly misleading. So we wanted to actually stick with this more scientific version. And why we did this is because I see a lot of people share on social media, for example, screenshots of, not to name them, but Space Weather Live 2-hour data, which is nice to see for like what is happening right now. But I always tell people once again that the solar wind is just not this constant stream of things. It has life in it. It's different structures, and if you cannot see things in, like, if you cannot see the bigger picture in another way, then yes, you're gonna see, okay, the BZ is like -5 right now, and you're gonna try to connect this with the Aurora, and you're gonna be like, ugh, one day is gonna be nice and the other day is not gonna be nice, and you're gonna be wondering why this is. And I think this is why you should use not the 2-hour data, for example, but this is like the default on our app. It's like the 1-day data, is because you need to look at the bigger picture in the solar wind, for example. And I know not a lot of people know about these structures and difference between these structures and how to decipher all these graphs, but we want to give them a chance to learn. And I think presenting in a way invites people to learn more. So this is our way of thinking, and that's why we present things this way. But could be better visually. I agree, but yeah.
I'm glad you brought that up, because that then adds another important point in that people want to learn. A majority, and I would say a high percentage of anyone even slightly interested in the Aurora, they're not trying to just get, okay, I want this number and that's that. I don't want to hear anything else. None of them are like that. They want to know what's going on. They want the information presentable. But the problem is, not only is it super complex, but then you don't have the ability to be super simple about what it is. You have to either forego accuracy for the sake of simplicity, or vice versa, in which case you get a large, not willing to listen generally audience. So the idea, of course, is, people want to learn. They're trying to figure all this out, but it's hard, and it needs to be presented in different ways. But we also, at the same time, need to make sure they know you can learn and you can be done, but you need to be able to stick through this. And you're going to ask a lot of questions, and that's fine, but have faith that the person can learn more than what they already know, rather than just staying in the realm of, we'll just deal with the ovation model for now, as an example.
Yeah. Agreed.
Agreed.
That was my rant on that side.
I like the rants. You guys always have lots of good points, so.
Well, I personally ran out of topic ideas. If anyone has any other ideas they want to bring up.
No, I mean.
I think you're muted.
Oh.
Oh, yeah. I don't know if that's
yes, I am. But... Sorry. I don't even know what I said. It wasn't important. I know that, but I think it was just about. I like listening to you guys rant about all this stuff. So it's because it's all important, and it's all things that we've been trying to slowly improve upon, as we've all learned more, and be like, yeah, there's a lot to this, and it's it can be frustrating at times, but it's really cool. It's fascinating, but yeah.
All right, well, here's another $1 million question I want to ask, and this might be more relevant to just Adrien and I, since we've been involved in a couple cycles now. Okay. But comparatively to, let's say, the beginning of cycle 24 or solar 24 max compared to now, what do you think the education level is like for the average Aurora chaser? Would you say it's improved, or that we've made progress in our hopes of expanding people's minds?
Yeah, yeah, definitely, yes. There's so many more resources out there. Even if we think personally that maybe there aren't many sources out there, there's so many more resources, and the fact that people can actually easily access them directly from the field or their homes is just, 10 years ago, there weren't even anything.
I think spaceweather.com, and then when Space Weather Live first started coming up around that time, that was the only two sources I could think of outside of NOAA, which even the NOAA dashboard has increased dramatically in terms of what kind of data it offers the public.
There was Solar Ham as well. I think Kevin has been.
Solar Ham, Kevin, yes, of
Mhm.
course. Kevin's
Yeah,
been
yeah,
doing
yeah.
his thing for ages.
But otherwise, yeah, I don't know if there was anything prior to that, at least on social media-ish slash, yeah, I don't know.
Other than groups just trying to figure it out, I can't really recall either. That's another reason I did my page, just to attempt to get education out more. And that was kind of a lead-in question because, of course, I agree with you. We've come leaps and bounds compared to where we were before. And not only do we have a higher percentage of people that understand things, but those people are then willing to also share and expand the knowledge with everybody else. And I would say the average Aurora group, no matter what it is, has a decent amount of people that at least are able to help answer questions and decipher data.
It's
Definitely in
been
a better spot than we
it's
were.
been an interesting cycle to watch too because, I mean, just comparing, I don't know, general camera cell phone technology now versus 10 years ago, and just how more accessible all this is to everybody. Really, I mean, like a cell phone 10 years ago probably could not take a picture of Aurora.
That's an extremely good point. Yeah. Now we have people with cell phones that are, not necessarily professional camera grade, but could very
Yeah.
easily now, through algorithmic processes, stack photos while holding their phone up to the sky and get decent detail out of the night sky, even in, let's say, a light polluted area like a city. I mean, again, May and October both were filled with tons of smartphone camera photos in the cities, and it really wasn't that bad.
It's really kind of pushed what we originally thought the visibility of this stuff was too. Like, you're just getting these really southern locations seeing, and it might not have been naked eye visible, probably wasn't, but these cameras have just picked it up and you're like, wow, that's wild.
Which
So-
actually resulted in some people adding that photography belt to visibility, and
Yeah.
we started to talk with how problematic those KP-based maps are. Well, they got a lot more complicated
Right.
and a lot more problematic because now people
Add that
expect
in.
that they're going to be able to take a picture of Aurora in that area. And that
Yes.
may or may not be true.
Very true.
Yeah, we,
So, of course, tech helps a lot, and then it adds to a lot of
Right.
problems.
I was just gonna say that. It's like, yeah, sure, yeah, it opened up this, but
Pros and cons to it all. Let's see,
Indeed.
any
As
other
usual.
questions we've got on here?
but I think like the 10th of May was the most photographed Aurora event
Yep,
ever,
probably.
or something.
Which makes sense given
Yeah.
how far south it was for how long it was, too.
Yeah.
I mean, I saw Southwest Florida photos. God, that's insane.
It's crazy.
San Francisco.
Yep.
Yep.
In the major cities. I mean, I wasn't even in a great area. I was in a parking lot that was fully lit up in a Portal 7, and we still had overhead corona
Yeah.
visible at
My
that.
friend Hugo was actually in San Francisco back then, and he was by the Golden Bridge. He
Uh-huh.
was like taking pictures of the Aurora, and this couple passes by him, and he's like, "What are you taking pictures of?" It's like, "Well, the Aurora." I'm like, "Are you kidding me?" Like,
Yeah, it's like, what?
Seriously.
yeah, crazy.
Like, no
My
way.
friend lives in San Francisco. She's been trying to chase Aurora all through solar cycle 24 and moved to California to catch Aurora there.
Yeah, that's ironic. Like, move
Yeah.
further away from the Aurora and be in a city, but now getting it more often.
Yeah.
Thank you,
She was
Cycle
saying
25.
it was eye visible. It was red, and I think the height was estimated for some of the substorms within that great storm at 900 kilometers.
Wow.
So
That's
that's visibility.
That is visibility. Wow,
Yes.
unbelievable.
Yep.
Yeah, I just had to say because Justin joined and he's like, "Oh, it's the KP Hate Squad." I'm like, "Yep,
Yeah, he missed
we,
it all.
we already covered that."
And
Yeah.
again, let's not say the hate KP squad. I mean, granted, it has a lot of disadvantages, and it's
it
more
has-
frustrating that it's a commonplace
Yeah.
number. But
It
it's,
has a
it has
purpose.
its place.
It definitely has its uses. It's just how it's used for aurora chasing is problematic. It's mid-latitude geomagnetic disturbance index. It really is not meant to represent aurora.
On this point, actually, because the rebuttal to that would be, but then why hasn't there been invented an Aurora index, for example?
As in auroral electrojet index?
Or
Well,
That never
DST,
caught up.
or
Yeah, that never caught
or
up.
should I say, like, why hasn't there been, like, where isn't there like a very global index that describes the aurora? Well, because, like we said, there's so much variability in terms of latitude and longitude happening every day, and it would be just, we cannot put this in like a global, it would not make sense to say
you
global because the aurora
you
is
can't
just,
describe a multi-dimensional issue with less than that many dimensional answers. The aurora is not a one number. It's just never going to be that case. Therefore, you can't represent it in one number because it's always going to have some variance off of it. You have to use whatever, I mean, again, whatever variables we have to deal with, whatever dimensions of freedom that the aurora can have in this problematic magnetospheric picture, that's how many answers that there need to be for it. It just gets complicated far too quickly. But of course, yeah, we've got the AE index, the DST doing the ring current instead. What do you want to look at? The HP30, we can go that route too.
There are ones that are based on supermag data, so it's SimH and ASIM. So what else do we have for Aurora? SH.
Yeah, I don't even know those.
SASL, yeah, those are kind of the upper and lower envelope in the supermag data. Just basically more stations and supposedly a little better, but it is more of a global index of disturbance in the auroral area, in a rural zone. Is it good? Well, it has some limits as far as how it catches response to substorms too. So it's definitely not perfect, but let's put it this way, tracking a rural electrojet would be better than tracking KP.
Yeah.
Or even HP30. Because again,
Yeah.
with HP30, you're looking at mid-latitudes. And it's good if you have a power grid there where that constant current is problematic because it's going to heat up some of the equipment and basically degrade it over time. But is it good for Aurora? No.
Let's see. I like what Mary Beth's conversation is going on right now. So the cycle 25 compared to the downward trend. Yeah, she pretty much stated it as accurately as I wanted to as well. But yes, cycle 25 is nowhere near. In fact, have you heard anything about a global Maunder minimum coming or Delta minimum, any of the grand solar minimum people talk in the last 3-ish years? No, they're quiet because it doesn't exist. It's not happening. Cycle 25 is, at this point, will likely finish under cycle 23 by a little bit. It will easily be an average cycle in comparison to the modern maximum we have going on, which then, as we mentioned with Scott's presentation, why was cycle 24 the odd one out in that case? If everything going in a downward trend, more so it's why is cycle 24 so weak compared to what everything else has been so far? Which, yes, follow the linker people, they're going to be the ones on top of that for sure.
Yeah, I think they're already trying to take bets on what 26 is going to do, but it's still a little early. So
yeah. I would agree. There is actually a very important point in chat because of that separation of science to more of the auroral community. The terminology is really something that lay people never caught on to.
Mm-hmm.
So trying to really find the common terms that we can agree on as sort of bridging scientific community to people who want to see Aurora would be a great thing. And trying to not dumb down the science really, but simplify the science and find a correct explanation, because you can dumb it down to the point where science is no longer valid.
Right.
I've seen enough of the explanations. I've seen enough of even pictures of how auroras supposedly work that are not scientifically correct. And then people get very confused as far as how things work and why they're seeing certain things, as opposed to, well, I heard this is the explanation, and then apparently that explanation is not accurate. So then we have to go back and explain why it's not correct, and then explain it in terms that people can understand. So our job is really to find that common language that can bridge the science to field operations and to people who just want to see Aurora, maybe once in their lifetime, maybe more than once, I'm hoping. But we do need to find that terminology. It just doesn't exist right now.
Weird.
It just doesn't. There's no shared terminology. Medical community, I'm a physician, so we worked on it kind of throughout several decades where explaining things and explaining medical science in terms that helped and make it accessible, make it easy to understand was actually a thing. But we did it together. We did it with patient community. We do have finally an international group that's bridging science and aurora chasing, and that's Arctics. And they came up with a handbook. We'll put it in the video description too. But those are first steps in the process.
Yeah.
Those are just very first steps in the process. This is a field that kind of separated. It's been kind of the field of almost like quantum physics, where you throw terminology at a layperson and they don't have a clue what's going on. They don't understand. So space weather has been like that for decades, and now people want to make it accessible, and scientists finally want to make it accessible. So we're in that process of developing vocabulary almost, a lexicon that will be understood and appreciated by both science and aurora chasing community. We're not there yet.
Working on it.
Nope. And of course, the difficulties are the fact that it is in its infancy. I mean, it changes once every couple of months. We go from thinking, okay, the ovation model is actually a decent oval or decent model to help figure out what the aurora is doing. Not even a year later, we go, actually, not so much. Now it's taking too much of the solar wind parameters. We realize the magnetosphere is doing something different. And then we move on from there. We move on so quickly. By the time we get some terminology to describe the last two things, we're already 3 steps ahead this way because that's how fast things are going. There's probably going to be a separation in some form or shape over the next couple of years just because of that. And until we have a more grounded science, which we need more satellites in space, then we're not going to get that information. And then we're going to have this giant divide between Aurora Chaser that's in the layman area and then those who are in the field.
Yeah.
Yeah.
Well, let's see. I don't know if we have any more questions. And I know that we've taken up a lot of Adrien's time here.
No, it's fine. You know
but
what?
It's been fun. So
looks like there's a substorm coming again. Oh well.
Oh, to have the convenience of being at that latitude.
Yeah.
Yeah.
Look out the window and it's
Like,
Like,
what's my magnetometer say? Oh, wait.
Interesting point about KP and magnetometers that don't really show what Aurora is doing by a long shot. Yes and no. KP, we talked about it. It is problematic, should not be used. Magnetometers, depends. It really depends. It really depends on how you're interpreting the data and what else is not showing up in the data. So it's almost like if you're looking at the data and saying Aurora shouldn't be there, that yet Aurora is clearly there in the picture. Either you're looking at the wrong data or you're looking at the data wrong. There is usually a way to connect what magnetometers are doing if there is huge aurora at mid-latitudes. Higher latitudes, that's a little different because some of the arcs, it gets really tricky. They don't have huge magnetometer response, like quiescent arcs that just sit there. They're more electrostatic than really electromagnetic. And you end up missing that. You end up missing some of the smaller stuff if you really have that magnetometer desert. So it really depends on where you're at, what Aurora is doing, but usually for mid-latitudes, it's really hard to miss Aurora in magnetometers, particularly if the magnetometer chain is very close to you. When it's far away, you're not going to see it. But if it's very close and it's mid-latitudes, it's going to show up.
Yeah, I agree. And then it depends on if you're looking at GOES.
I think the connection between the auroral electrojet, but the assumption is to say that the auroral electrojet is assimilated to the auroral oval, and this assumption, which has long been disputed, like in the past, now has been demonstrated more and more and more, and now people assimilate the auroral electrojet current with the oval, and it's not for nothing. And you're right, Tanya, to say that magnetometers, if you look at things the right way, you should be able to see really what the aurora is going on. Of course, it's never 100%, but at least it gives you a right idea. You touched on the quiescent arc and the growth arcs, and that's why our model doesn't show this evening aurora well. Usually it's very quiet there because it's very hard. Usually magnetometer, the H or X component of these are very close to their trace, to the base trace. and it's very hard. You don't know if you're in the eastward electrojet, westward electrojet. You don't know what's going on, if there's a surge of aurora or not. Usually you're not going to see that much surge in these components. So it's very hard, but when you're usually into the, or close to the auroral electrojet, and especially the westward electrojet, these surges, they do mean something, and you will see at some point some kind of brightening in the aurora, because the auroral electrojet, it's such a strong current of the ionosphere. So I think that's why the connection has been, made more and more between the two. And I know James, he's a long time chaser, and yes, sometimes the magnetometers data, they do not reflect precisely what you're looking at, but on average, it does give you a good idea of what's going on, I think.
Yeah, I would have to agree.
Fun times.
Oh, I love these chats. I mean,
Yeah.
so much going on in the chat right now. I cannot keep up with
I
it.
know, it's good.
And these were exactly what I was hoping for this type of presentation.
Yeah,
or
it
discussion,
really
I
is.
should say.
Having
It's all about
both-
the discussion.
Yeah, the discussion and having the audience input too is really cool because that helps drive it. And then, of course, I was trying to respond, and I guess I didn't have the mute on completely, so people were hearing me type, and that's not, sorry about that.
That poor mute button.
Poor mute button, but that's why we're unplugged and informal. So Justin wants to know, how's the weather in your neck of the woods? It's clear, right? Because you said you can see the moon in Aurora, so I'm assuming it's good.
Yeah, it's surprisingly clear tonight. So we're having a I don't know. There was a growth arc just above, a little bit past overhead for us, and it seems to be brightening a little bit and starting to swirl. So perhaps we'll get something, perhaps not. I don't know. Only one way to find out.
Yeah, there's only one way to find out.
And that's to look outside.
It is. Wait,
Yeah.
Ooh.
I see the arch. Can I bring my computer in there?
Yeah,
Oh,
no,
that's
this would
hopefully.
be cool.
Ooh.
No, wait, it's gonna fall down.
Darn it. Okay. That would have been cool. Just poke it right out there.
It's like live from Norway.
I actually, at the beginning, I had the idea of trying to plug my camera to this.
Oh,
I'm
right,
not sure
yeah.
But that would have been awesome. But then I wouldn't have been able to show the slides and everything.
Right.
So
Yeah, I'm sure
it's
there is a way to do it, but it's like you have to have multiple, like a switchboard almost, where all the things are plugged in.
anyway, I can see the your background aurora. So.
Yes. This is always
Her
on
constant one.
all the time, even during the day. Like right now, it's just going
Like a constant substorm expansion. That's perfect.
constant.
What she did was slow time down and was able to capture that moment in time over and over. It now exists physically in it without her time slowing down too. Doctor Who terms, at least. Right, it looks like a few
funny.
people are having to leave. I'm good with wrapping it up at this point.
Yeah.
If you guys are okay with that or want to continue with anything else, but I think we've had a good couple-hour discussion.
Pretty much, darn near 2 hours. So, I think it was great.
Wow.
Yeah, thanks so much for doing this. This was a lot of fun, and it panned out
Yeah.
basically how I was hoping. Like, we just
Same, yeah.
we just take it wherever it goes. Like, this is the direction we're going. So
Yeah, thank you so much. It went into a lot of many directions.
all good though. All good discussion.
All what I was hoping for.
So maybe he'll come back on. One of these times we'll have another panel discussion.
Awesome.
We should have an actual panel. Like, it'd be cool to have maybe Tamitha and Scott come back on for just a couple different occasions. Have Adrien join. I personally wouldn't mind seeing some new people too.
Yeah, that could be
We
fun.
could have like a once every 3 or 4 month panel, like 5, 6, 7, 8 of us just pitching in on a topic.
And I think
we
it
can
would
figure it
be
out.
cool too, because then we'd have people on the the solar science side of it with the Aurora Chaser stuff. I think that would be really kind of interesting. I think ideas. I like this.
Yeah, I agree.
So anyway, I will end this on here, but thanks everybody for joining, and thanks again for Adrien for coming on here and taking time away from chasing Aurora to talk to us.
Thanks for having me, guys.
Yes.
It's not great Aurora anyway, so it's basically Aurora for us. Just kidding.
Fair.
Yeah. And in case don't talk to anybody else in the chat or whatever, I mean, we might do another one before then, but happy holidays to everybody out there, in case we don't chit chat again. So, but thank you so much.
Absolutely. Happy holidays, everybody.
Okay.
Happy holidays.